Hello everyone, thank you for joining again the Spring Security stream. Wow, it's already lesson 5 and we are going to discuss about the filtered chain. So if you are watching the event live, don't forget that you have a live chat there so you can ask questions directly in the live chat. And if you're watching the event recorded afterwards, you can still ask questions in the comments section, or you can find me on LinkedIn or Twitter, of course, and I will try to answer your questions in a separate video or in the next lesson. So let's see the filter chain. This is the topic for today's lesson, and I have prepared here already for you a couple of diagrams so that you remember what we have discussed in the first 4 lessons, and that you know where we are and where are we actually going, what's the next steps. And then we are going to write another example, as we are always doing. We apply everything, put it in action in an example with Spring Boot and Spring Security. So you do remember, I hope, this diagram, which is the, let's say, the fundamental diagram, the backbone diagram of Spring Security. And you remember that the requests are intercepted by the authentication filter, and then the authentication filter delegates to the authentication manager, which we have seen in the previous lesson that might have multiple authentication providers. While it's true that in the previous lesson we did only implement one authentication provider, so that you can see how does it work, how does an authentication provider look like. And that's because we have used in the first couple of lessons only the default provided authentication provider, and you didn't know how does this contract look like. And you have learned about the authenticate method and the method supports that we override to specify when is a specific authentication provider applicable. But we have the possibility to have actually multiple authentication providers, and we do have multiple authentication providers to solve different kinds of authentication objects. And these authentication objects actually come from the authentication filter level. And this is where, again, this is what we discussed today basically, is where you will learn that this authentication filter is again simplified here a lot in my diagram. So you only do see a filter here, but this filter is actually part of an entire filter chain, and it's called a filter chain because there are multiple filters and they delegate one to the other. So they apply their responsibility and then they delegate to the next authentication filter. And this is what we are discussing today. We are discussing about the filter chain and how can you customize the filter chain. And then that's for the next lesson. We will be able to have multiple authentication providers and then discuss the security context. And then we can say we finished this backbone architecture of Spring Security, and then we go further and discuss the OAuth 2 part. So there's a lot of things to discuss in the near future in this stream. So stay tuned and follow the lessons because you will have plenty of things to learn, things that you will apply in real case scenarios, things that you need if you want to secure up your applications with Spring Security. So I hope that you do remember now this backbone architecture, and down below I have represented the filtered chain. So it's only this part here that for the first 4 lessons I have referred to as only one filter, and I have called this filter the authentication filter. You will now learn that this filter is basically part of an entire filtered chain. So it's one of the filters that apply their responsibilities in over the HTTP request when a call is made. So here is basically how can you imagine it. We have the request and we have the response. So the request goes and it will be forwarded from filter to filter. You might have multiple filters. Some of the filters are already provided by Spring Security. You will see that we have some filters that do apply some kind of protection. We have, of course, the authentication filter. For the moment we have used the basic authentication filter, and that's kind of an implementation filter provided by Spring Security. but there are other filters besides this one. For example, you have a filter that takes the responsibility of applying the protection for CSRF. You will have the configuration for crossover request sharing. We have other filters besides the authentication filter, and besides all these filters provided by Spring Security, you can add your own custom filters. So you can create a filter and add it before, after a specific filter in the chain, or you can even put it at a specific position of a defined filter in the chain. For example, if you want to customize your authentication, and this is exactly what we want to discuss in this lesson, you will replace, it's not actually replace because you don't have it there already, but you will add a filter, a custom filter, a filter of your own definition at the exact position of, for example, the basic authentication filter. So this is what we want to do today, and by this you will learn how to customize the filter chain. And of course I will deal with very simple examples, but they will become more and more complicated with the next lessons. So from my point of view, it's really important for you to understand really well the basics with simple example, because maybe you'll think they are not real world scenarios, they are not applicable. But even if these very simple scenarios are not applicable now, they are the base that allow you, that enable you to understand the basics of a specific component and a specific architecture. And then we will complicate these examples and we will bring them closer and closer to real case scenarios. So what I plan for today is to create a filter, a custom filter, that only tests if you have a specific header with a specific value. This is something that's probably not really, you won't encounter this directly like this in a real case scenario, because it's too simple and it doesn't really protect a lot your application. But as I will tell you while working on the example, we might think further that instead of having that, let's call it simple string that we will use like a key, you will, for example, in a real case scenario, use a token. And in order to understand first what the token is and where does it come from, who is managing this token first, and how, you first need to understand the filter chain with a simple example. And then when we go in the next lessons further, we will use more and more complex implementations, and then you will be able to understand the complex implementations because you have already understood how the mechanism behind that works. Otherwise, probably if I would just place everything, all the new information in front of you, and you have no experience with this, then it will be very, very difficult to digest. And that's why I'm taking it step by step, and I wanted to understand very clearly this architecture, this mechanism, the way Spring Security works. So yes, before going to the order, so the third diagram that I have here, we can already go and start a new implementation, because we want to apply everything and to make sure that you understand how to implement it, not only to understand how it works in a real world scenario. Probably you need to implement it and not necessarily only to know the theoretical details of all these things. So let's create a separate project, and I will use my Spring Initializer option here, and I will create a Spring Initializer project with the artifact as usual. I think it was C4 and now it should be C5 because we are at the 5th lesson, and we can use the latest general available version, which is still for the moment Java 13. And then we choose our dependencies, and we are still creating a web application, so I will add the Spring Web. And then we need, of course, we are discussing Spring Security here, so we need a Spring Security. This example being a very simple one, we don't have any database, we don't have any kind of other related stuff, so we don't need any other dependency besides these two dependencies. So we do create next our project, and I can keep this one and close the other one so I can spare some resources. like this. Okay, still a little bit is resolving my dependencies here, and in a couple of seconds, I hope not minutes, it will have all the needed dependencies. Perfect. So I can just continue with my application, which is a very simple blank application. Now, of course, as usual, I will create a very small endpoint very fast, so we have something to work with. And you know, I always use a very simple controller. So my hello controller class is annotated as usual with the REST controller annotation, and then we have our demo endpoint that only returns hello, and we do annotate this with get mapping. And we are very close to discuss also how to use post, put, and delete, and discuss more about CSRF, but we still have to deal with the filters first, so that's what we are doing today. And yes, indeed, now we need of course a user, or as you know, if I would run my application exactly as it is now, I will have to use the username, user, and the password that Spring Security would generate in my console. But again, what I want to do with this application is that I don't want to use the HTTP basic authentication method anymore. I want to implement a custom authentication method. So I don't want a username and a password. I simply want to have a specific string, like a password, and if the request contains that password, then it will be allowed. If it doesn't contain the password, then it won't be allowed. Very simple example for you to understand the entire flow from the filter to the authentication provider. So how do we do something like this? Let's assume that the password, because it's a very simple example, is just a key that we define in our properties file. So key, and this is my string ABCDE. So let's assume that we want to approve all the requests that have in their authorization header on the request the string ABCDE, so the string that matches precisely with the value that I have added here in my application properties. This is something that in the future will become a token, and instead of having the key precisely that you will compare, you will have a key which you use to sign, which can be a symmetric key or an asymmetric key pair, but that's something that we discuss in the future. Again, the things in a real world scenario would be a little bit more complicated, but to reach those scenarios, I want you first to understand how the filter works. So I will keep the example very simple. I want to authorize the requests having the authorization header with the precise value we have in this properties file. Can we do something like this? The answer is yes, we should be able to do something like this. So let's see how can we create such a functionality. First of all, we can observe that in this case we don't have anymore a username and a password, so it's clear that the base HTTP basic authentication method doesn't apply anymore. So you have to create a separate filter, a separate authentication filter. If I wouldn't declare an authentication filter, as you already know because you have seen in the first 4 lessons, I will have the authentication filter with the implementation of the basic authentication filter that is by default provided by my Spring Boot auto configurator. Now, if I want to have a different authentication filter, then of course I need to specify my own authentication filter. So let's do this. Let's create our own filter. I will create here a package. Let's call it security. And in my security package, I will have 2 other packages actually that I need. One of them will be the filters, where I will define a custom filter, and then I will also follow the exact same architecture of Spring Security. Even if it is very simple, the example, I would create an authentication provider to treat my authentication logic, because this is the correct way to do it. even with a very simple implementation. Anyway, again, in a real case scenario, it won't be that simple, so it actually makes a lot of sense to have them separated. But the reason for why I do it also for a very simple implementation as our scenario here is because I want you to be used with how real world scenarios are implemented and not only with theoretical way of working. So I have the filters and I will have the providers, the authentication providers. I will call the package providers. And then another thing that I need, of course, again, is to have my configuration. And my configuration class, I will create it inside my config package, project config, let's call it like this as usual. And of course, to be a configuration class, then I have to annotate it with the add configuration annotation. So I will come back later to this class. I have it now, it's empty, it's just a configuration class. I will need it to define and to configure my filter for the application, but I will do this a little bit later. For the moment, what I do is just I create my filter here. So let's call it my custom authentication filter. I do create a class here, custom authentication filter. Okay, I hope that the name is correct. It looks like fine. And what you need to know is that in Spring Security you can directly use the contract that comes from the Java Servlet package, which is the normal HTTP filter you find defined in the Java Servlet package. So I can directly say implements filter, and you select the correct filter, because you see there are plenty of implementations, plenty of interfaces for filters here. This is the filter that we are looking for, the Java Servlet filter. And you can directly again implement this contract, and then you will have to override the only abstract method of this interface, which is the do filter. The do filter, for those of you who didn't work with a web application such in detail to learn about filters and servlets, the do filter is basically receiving the request and the response. And the third parameter you see here is the filter chain, which allows us to delegate further the request. So we get the HTTP request and we can alter the HTTP request while we intercept it. You have the response, so you can alter the response before it's sent back. And you have the filter chain, which allows you to delegate to the next filter. So like in our diagram here, if you remember, we have more filters. You can imagine they are like a chain, one after the other, and they apply one after the other to the request. So imagine we create this filter here. When we want to delegate the request to the next filter, we use the filter chain, and that filter chain allows us to pass the request further to the next filter. And basically each filter does precisely that. It can use the request and the response, and then it can pass the filter the request to the next filter, and so on until the chain of responsibility ends. So this is what we should do. We should implement a class that defines this contract. Now, if we do implement directly this contract, we will have the problem that we'll have to cast this parameter here is of type HTTP servlet request. So it's of type servlet request, and we actually use HTTP as a protocol. So our implementation it will be of type HTTP servlet request. Because we don't use HTTP servlet request, we will have to cast it to an HTTP servlet request and obtain to be able to obtain the headers that we need. So I will show you precisely what I mean, because I will start my implementation with implementing directly the filter, but then I will show you how to change it a little bit, let's say, to make it easier, cleaner, by using an abstract definition, an abstract class definition from the Spring Security itself. It's called once per request filter. So let's start with the filter definition by using the filter contract, which is let's say the most low-level way to do it. We directly implement the contract, and then you implement the contract, you override the do filter method, and you have the request, the response, and the filter chain. You can see it here. I usually call this request and this response to be easier for me to refer to them, and chain. And I can here try to obtain the authorization header. So if I want to obtain the authorization header, I should write something like this. So I can't say request get header. I don't have the get header method here because the get header method is only available for an HTTP request. So that's why I should say something like HTTP, and then I have to cast it to an HTTP servlet request is this one. It's a request, and then I have to cast my request to the HTTP servlet request implementation, and then I have to use I can use the get header for obtaining the authorization value. So this is the authorization value of the authorization header on my request. And when I now I can use it, I can basically use it to write my authentication logic. In this case, I should actually deliver the authentication logic to the provider, and then at some point, if everything is fine, I say, okay, now delegate to the next filter in the chain. So this is how we delegate. We call from the chain the do filter with the request and the response, and then we have the authorization logic. If we follow precisely the way in which we have to do it, if you remember from the past lesson, from the previous lesson, actually from lesson 4, where we have implemented our own authentication provider, you know that the filter always has to delegate the responsibility to a manager. So in our case, the authentication filter has to delegate to an authentication manager. So that's why we have to inject the manager here, and then we will delegate from the manager the authentication object to the authentication provider, and the authentication provider is the object using the authentication and applying the authentication logic. If this is the first lesson that you see, mind that this is actually the 5th lesson of this stream, and we have discussed already plenty of things, and I do consider that you already know them, so that's why I'm explaining them faster. If you don't know them, you can anytime go back on this channel and review the first 4 lessons where I discuss already about what the user detail services, password encoder, this entire architecture, the authentication provider, because now we are already discussing about the authentication filter. So what we need to do is to make the authentication provider available to our authentication filter. So to do this, we can inject it. If we make this a component, then it's part of the Spring context, so we'll be able to use AutoWire to inject an authentication manager. So I do here try to inject an authentication manager. Okay, here it is, and you will see if I try to add the authentication, the AutoWire.notation above to inject it, you will see that basically there is no authentication manager by default in the context. So I will need to do this, and I will need to inject it here so that I can use it further to delegate my authorization, but I need first to make sure that I have an authentication manager in the context. It's pretty easy to put an authentication manager in the context because you can do that directly using the @b_notation in the configuration class. So now to have the manager, and you see that IntelliJ here tells me that there are no beans of this type. IntelliJ is pretty smart and already shows me that I tried to AutoWire something that doesn't exist in Spring context. So let's put it there. We go to the project config class, and then to put the authentication manager in the context, I do extend the web security configurer adapter class. You know already this class because we have used it in the previous lessons as well, especially for overriding the configure method. This time I won't be overriding the configure method, but I will be overriding the authentication manager bean method, and I will I will leave this method basically return the result that is already returned from the method of the superclass. So I don't change, basically it's an overriding, but I don't change its functionality. I will simply return whatever it comes from the super definition, but I do this overriding basically to add a bin above the method, and by adding this add bin above the method, you know that in Spring this means that I will add in the Spring context whatever is returned from the method. So that means that whatever the definition of the authentication manager is provided from the superclass, then I put it in the context. So this is the only reason for why I write something like this. And if I do this, now what do you expect? Going back here, oh, the error has disappeared, and that's exactly what we expected, because we now have an authentication manager in the context, so we can delegate our authentication. So let's see what happens next. Well, we need an authentication object. If we don't have an authentication object, then we can't call the authentication providers. You see here, if I want to authenticate, then I have to call the authenticate method of the manager, and this authenticate method of the manager, as expected, receives an authentication and returns an authentication. And you know that if it returns the authentication, it should be a fully authenticated object. If the authentication fails, then this should throw an authentication exception. Is the rule we have discussed when discussing the authentication provider in the previous lesson. So how do we get such an authentication object? Well, generally you would have to implement the authentication interface. You know, we have again discussed the authentication interface also in the previous lesson. Authentication, okay. So let's see if we can find the contract here. Seems that my IntelliJ is not that as fast as I expected, but we can do it like this, and it's the same thing. So you see, if I would try to do this mind that I would have to implement a lot of methods. You can see here that I do have to implement a lot of methods, and that's basically what I should do in a real case scenario. In a real case scenario, you do implement the authentication contract, and you do implement everything related to your authentication. Now, to save some time, what I'll actually do, I will use an already existing implementation of this interface, and this is the username password authentication token. So if you see this class, you might remember that we have discussed it in the previous lesson very briefly. It is an implementation of the authentication contract. Basically, it extends this abstract authentication token, and then you can see that the abstract authentication token implements the authentication contract, so it's an authentication object. It is exactly the authentication object used by the HTTP basic authentication method. So I will reuse this object, because I don't want to override and create my own class, so just to spare some time. So what I do here, I will create an authentication object actually, but I will extend the username password authentication instead of implementing directly the contract. So in my security package here, I will create another package called authentication, and then inside I will create a class called custom authentication, and this class custom authentication will extend, in my case, the username password authentication token. And you'll see that because it doesn't have a constructor with no args, we will actually have to define the constructors here, otherwise we have a compilation error. So this is it. I have defined the two constructors that will call their super versions coming from the super class here. So now we have an authentication because we extend the username password authentication token, which extends this class, which implements authentication in the end. So we have an authentication. So this is basically what I want to use. I'm going back to my filter and I will create a new authentication object using my custom authentication class. Custom authentication is here, and then you see that I basically need to provide a username and the password, because this is the way the username password authentication token works. What I will do is I will provide the object that represents the user, which will be my key, and I will basically use no credentials. You see that that's precisely what I'm going to do. I will just use it. Again, it's not really a correct way. In general, I should have directly implemented the authentication contract, but then I would have had to override all those methods. Now I simply reuse it a little bit forcefully, this username password authentication token, but it's simple for our example now to do it like this. So that's why here now what I do, I pass the authorization and then I will provide a null for my credentials, and then this object goes to the manager to get authenticated, and then what we expect back is an authentication itself. And because I have here a contract authentication, I will call it the authentication result, because by using this var here, it will take the custom authentication type, which is more particular than the contract itself. So I will simply say authentication result. Okay, and it should be like this. And then this result here, what the filter should always do, if the authentication is authenticated, again, in general, it should be at this moment, it should be authenticated. So I say result is authenticated, and then I will delegate in this case to the filter. Generally this condition is not necessarily needed, because if the developers respect the rule in which the authentication provider should throw an exception if the authentication fails, then we should always have the situation in which either this line throws an exception or the result is authenticated. It is not really possible in a correctly implemented situation that the result is not authenticated. But I usually, depending on who I work with, I usually tend to be very cautious and also do this test and eventually even throw an exception in case I have here a result which is not authenticated, which shouldn't be the case. And of course, again, what should always a filter do when it gets the authenticated object, it should move it to the security context. We will learn in the next lessons that the security context is the place where the authenticated authentication is stored, and that's where the authorization rules are applied. They know the authenticated user, and they can be applied. So that's why here I can say security context holder get context set authentication result. So I put this result in the security context precisely like in my diagram. So it goes down, the authentication filters go to the manager finds the provider. If needed, you also have a user detail service or a password encoder. It's not our case, because in this case we don't have users and passwords, but remember that if you do have users and passwords, you need these components to have separate responsibilities. That's why basically I have a dotted line here to represent the fact that this might not be part of the diagram all the time. Anyway, somehow the provider manages to authenticate the request, and then at the end the filter puts the information of the authenticated object in the security context. Generally, and that's where you should be attentive, by clearing the credentials. So you should make sure that if you have sensitive data wherever it applies, where it's applicable, don't store it. So be careful make sure that that information is only available as long as it's needed. Don't use it more than don't keep it more than it's needed. So now we go back. So you actually did implement everything now, because you have the manager, you get the key used for authentication from the so-called authorization header, and then you create a custom authentication object, which is a class we have defined, which at some level it implements the authentication contract. That's why we can send it as a parameter to the authenticate method of the manager. We try to authenticate, so the authentication, we get a result, and then we store in the security context, and we filter further to the next filter. So that should be actually it. And now we have the filter, we have the object, we only need the provider. We need also the provider. So we did the filter, we injected the manager, we have the authentication. We need to define a provider to allow our implementation really do the authentication, because the provider is that component where you implement the logic for authentication. So let's create this custom authentication provider, and this will actually be a component in my Spring context, because I would like to inject it first of all in the configuration class, but I will also like to use some auto wiring here as well. It should implement the authentication provider interface, and of course it should override the two abstract methods of this contract. So we do have to override the authenticate and supports. And you know that supports, it tells the manager, the authentication manager, if this specific authentication provider supports some kind of some type of authentication. In our case, the type of authentication we use is that custom authentication we have created ourselves, is this one here. So this is the class we need to support from our from our provider. So we go to the provider and we say something like this: class equals a class. So if the authentication is of type custom authentication, then it is supported. And then we have here to take the value of the key from the properties, and we can do this pretty easy by using the value annotation. So I think it was actually named key, and it is this one here. We define in the application properties, and now we can implement the logic itself, where we take from the authentication, we take the name is the place we have the key from the request. So we say request key from authentication get name, and then we can say if request key equals to key, then we will create here an authenticated authentication, and we will return it. Else, of course, we have to throw an authentication exception. I usually use bad credentials exception. Okay, doesn't really matter for our example what the message is, but in a real world scenario, please do use a proper message here, so you know what happened in case something is not working. Okay, so this is it. Now you can delete this actually from here. This is a runtime exception, so it's only here for documentation purpose. You don't need to have it. And we need to return the authentication. So let's say the authentication, and we'll use the custom authentication of ours. Then you need to use actually here the second constructor that sets also the authentication as authenticated. That would be we don't have, in our case, we don't have anything. We don't have a name, we don't have credentials, we don't have anything. let's see if at least we don't have any kind of validation from the above constructor, because that's the downside when you don't implement your own class and you use something already implemented. So no, I actually think we are fine and we are safe. We'll see it at the end, but I think we are safe. Usually this would be the username, in our case the password, and this would be the collection of authorities, but our simple example is way too simple to have anything like this. So in the next lesson we'll implement a much more complex example where we have multiple authentication providers, and then we will have all of this. But in our case we don't have, so it's only a very simple example to show you how to set a filter for applying your custom authentication. So we create this and then we return it from the provider, and that's basically our authentication logic. And if we do have now all these objects and we have created the filter, we have delegated the manager, we have defined our own authentication provider, we don't need the users and passwords because we don't have users and passwords, we have stored in the end the authentication, we have actually managed to create the entire flow. So the only thing we still need to do, and for which I have to go back to my application, is to actually make sure that I do configure my authentication providers and the filters, which is pretty easy basically. First of all, I need to inject them such that I will be able to use them. So my filter, what was the name of the class? It was custom authentication filter. So private custom authentication filter, this is my only filter. I will auto wire it here so that I can set it up. And we have the custom authentication provider, probably provider, and of course I need to auto wire it as well. And now I do override. You have learned that, you have learned that we have to override the configure method. So I will actually have to override both configure methods here, and that's the one having the authentication manager builder, and as well the one having the parameter of type HTTP security. So both of them, we need both of them in our case, because this one will be used to configure the provider itself. So authentication provider, and the second one, we'll use the second one actually to configure the filter. And we have multiple ways to configure the filter. Basically we have 4 methods. If you just search for filter here, you will see there are 4 methods, and the most used of the methods are these 3, where you do have the possibility to choose a place in the filter chain where you want to add your filters. So how does this actually work? If we go back, I have prepared here the third and last diagram of ours. Each filter in the filter chain has an order, and the current implementation, which is not really important, but the current implementation identifies with a number each of the filters, and by default these numbers are from 100 to 100. So the first filter in the chain will have the order 100, the second one will have 200s, the third one will have 300s, and so on. So what I can do, and what we actually do here, we imagine we have the filter chain. We didn't discuss about other filters, but we have other filters there, and I want to be sure that I add my custom authentication filter precisely in the place where the basic authentication filter was. So if I want to use to add a filter, a custom filter, at a specific location of another filter, like in my case, the exact location where the basic authentication filter should have been, then I can use the add filter at. Then I have those other 2 methods where I can add a filter before or after a defined one. So that's why we have here multiple methods. When I do want to add the filter at a precise location, I use this method. If I want to add my filter after a specific one, I use this one. If I want to add it in the chain before a specific one, then I use the other one. If I don't care about the position, then I use the first one here, but that's pretty rarely happening. So I will add the filter at here. My filter is called filter, and then the position, the filter where I would like to replace, not replace because it's not there, but the position of the filter where I want to place my filter would be the basic authentication filter class. So this way I tell Spring Security that in place of the basic authentication filter, I do want to have my filter here. And now I have the provider, I have everything basically, and nothing to stop me. Probably because I don't have any authorization for the moment, I don't have any roles and everything. I would have to actually do the authorized requests, any request permit all here. So in my case, if it passes authentication, then it will be permitted. Generally, this would not be needed to happen, because you see here we do put our we do place our authentication in the security context, but the way we have implemented now is that we don't have a pretty complete implementation of the authentication, and we don't have any authorities to on which the authorization can be done. So that's why in my case I will completely skip authorization. I will only refer here to authentication. That's what I'm expected to happen. And basically, in a real world scenario where you create a more complex authentication, where you should have also some authorities or roles, then you will apply, instead of the way I've done it, where I don't authorize anything, then you will apply your custom authorization. But with this, and I hope finally we have done it in a short time, we have implemented, and that was the plan, we have implemented top to bottom the entire architecture. So we implemented a custom filter, we delegated, we have seen how to delegate to the authentication manager, then how to implement our authentication provider thing that you have also seen in the previous lesson, where we did implement the authentication provider but not with a custom filter, and then we have stored it in the security context. And that enables us that in the next lesson we will write a more complex example in which we will have more than one authentication providers, and we will have more than one filters. For example, if we want to implement a multi-factor authentication. So I will show you how to think a scenario in which you have to implement a multi-factor authentication, and what should you do in that case. You will see that in that case basically you will have multiple filters, multiple authentication providers, and it really depends on on the scenario precisely how many there and on the other side. So stay tuned, because we will have to develop a lot more this example, but I hope that you have understood now how to create a filter and what happens inside the filter, how actually the delegation goes from the filter to the authentication provider, and how to configure the filter and the provider when you have a custom definition of authentication. Of course, we have a few more minutes, and I will end my example with testing the application. So let's run the application and see if we didn't miss anything. And in case we didn't miss anything, we expect that the authentication will work by using the ABCD value for the authorization header in the request. And if it doesn't have this value, or if it doesn't have the header at all, then it will fail and it won't be authenticated. So I see that my application started, and I have a postman already prepared here, and we create a new tab. We have a get endpoint, HTTP localhost, and it will be hello. And then I do not here, I do go to the headers and add my custom authorization header, A, B, C, D, E. It was the value I would expect. And then you have a 200, okay, and you see the response. Now if instead of A, B, C, D, E I put something else, then you expect to see a 500 internal. That happens actually because we didn't set from the filter the 403 or 401 ourselves. We should have done this, because otherwise it will automatically it will actually throw the exception that was generated by us. It was that exception that we have thrown when the authentication fails. So the behavior of our example is still correct. It does not allow the authentication if you don't have the correct value in the authorization header. We still have 1 more minute, so let's try to also use the filter to write a better, let's say, response status. So in this case, of course, that means that I would try to cache the authentication exception. And it's authentication exception and not bad credentials, because by the contract, remember that the authentication that the authentication manager is supposed to throw any kind of authentication exception. So that's why I'm here retrieving the authentication exception. And then in this case you should go to the response, which will be that would be the request, HTTP request. Let's change a little bit the names here so that it's clear what happens. And then we have an HTTP response, HTTP servlet response is this one, from the response. And then on the response you should be able to set the status, let's say forbidden. So and that's if I consider here that I have also on the else side of the if, I should have written the same thing like in my case here. And basically that's it. And you see that I've started with the filter, and I've told you at the beginning of the lesson that I will show you also a custom class. I will use it in the next lesson, but I will also show it very fast here after I test again my example. So the hello is here with a wrong value, and you see indeed the 403, so that looks nicer. It's no longer that ugly exception. So A, B, C, D, E, A, B, C, D is authenticated and works, and anything else is a 403. So this is my implementation, and it works, and it's pretty cool. Now, I really dislike the fact that I have to do this casting here. I really dislike castings in general. I don't like to use this casting and converting operator. So I do avoid it as much as possible in my code. And in this case here, I do implement directly the filter interface, so I have no other options. But Spring Security offers us some already implemented alternatives for classes, basically abstract classes that you extend, and they come with different implementation with supplementary implementation. One of them, and maybe the most used class out of this, is the once per request filter. This once per request filter class, as the name suggests, not only represents a filter, but it's a filter that is guaranteed to be only called once in the filter chain by Spring Security. So it already somewhere here implements the logic for it. It already does the cast to the HTTP servlet request and response, and it also has some methods that we can override to specify when the filter, for example, doesn't apply. I will discuss more about these details in the next lesson. But just as an idea, is not only just the contract is coming with some implementation above the contract. You don't override the doFilter method. In this case, you see this is final, because here it is where this abstract class applies all of its functionality that comes above of the contract. But it's a different method, abstract method here that you do, and that's the doFilter internal. You see the doFilter internal directly receives the HTTP servlet request and HTTP servlet response. So in my case, what I actually do, I take this method, and maybe it's too difficult to copy it completely. I take this method, and basically that's what I override here. And of course here I don't have anymore the HTTP servlet request. The servlet I have directly the HTTP servlet request and directly the HTTP servlet response, and then I don't have to cast them anymore because they are already with the proper form. So here these two lines, I don't need these two lines anymore. And of course this is the request and this is the response. So already cleaner because I took out those castings, and that's by using the extension of the once per request filter class instead of directly using the contract. So in this case it really helps me to make it a little bit cleaner. Again, I dislike using castings as much as possible. I try to take them out from my code. So in my case, using the once per request filter instead of the contract directly helped me first with this way to clean those couple of lines of code that were ugly. And as you will see in the next lesson, also once per request filter will help us decide at the execution if the filter is or not applied, and we will create more custom filters, and we will decide when are these custom filters applied and when they aren't applied. So we can decide that a specific filter is applied for a specific request, and that's pretty nice as well. So again, the purpose of this example was to make you aware of the entire implementation, to implement somehow a filter, see that the way we delegate to the manager, see the way it's delegated further to the provider, and so on and so forth up to the security context. A very simple example indeed, maybe not realistic for if you compare it to what happens in a real application, but is the starting point from where we can now put on more and more and implement more filters, implement more authentication providers, and make sure overall that you understand the whole backbone architecture of Spring Security, which is really important. So from my point of view, understanding this architecture is quite the most important thing before starting with any implementation of Spring Security. This is the architecture which applies to the simplest example, the simplest application, up to the most complex applications with OAuth 2, the OAuth 2 grant types, and so on. They all relate on this architecture here that you need to understand and you need to know how to customize. Okay. So this is it. I will stop here with the current lesson, and I have touched. I consider that I have touched my scope and the objective for today. You will find this as usual on my GitHub account. I will leave the link in the description of the video and in the comments. And thank you very much for being here. Hope to see you soon for the next lesson, where we continue with discussing filters and the authentication providers, and I will create together with you a more complex example where we try to implement a multi-factor authentication and see which are the best practices you have to apply when implementing such an example with Spring Security. Thank you very much for being here with me, and have a great time for study.